Hello dear students, I hope you all are fine. You all are doing well and you are enjoying and learning a lot through our lectures. Students, today we are going to start with a new chapter that is included in class 11th NCERT, and the name of that chapter is Binomial Theorem. Now as far as the applications of binomial theorem is concerned, binomial theorem is widely used in the field of combinatorics, algebra, calculus and other parts of mathematics as well. Because the generalizations and expansions that we study in the form of result of this chapter are used in connecting the chapters such as probability, binomial theorem and permutations and combination. So these three chapters are connected with each other. And as far as the subject wise, the weightage of this topic is concerned, it is going to fetch you 4 marks in JEE examination. Because every year one question is being regularly asked in JEE mains exam. So students, let's get started with the chapter binomial theorem. So our first subtopic is binomial theorem for non-negative integral indices. Alright, let us first understand what do we mean by a binomial expression. Binomial expression. So I can say that any expression having two dissimilar terms or variables connected with plus or minus sign. Alright, for example, if I have written y equals to 2x plus 3. So here I have one term as 2x and another term as 3. So this expression will be termed as a binomial expression because I have two dissimilar terms or variables. Alright, similarly we can have numerous examples like x square plus x cube. These two are also dissimilar, so it is a binomial. Similarly, I can write x square plus y square. These two are dissimilar, so this is also a binomial. But what if I write x square plus 3x square? Now x square and 3x square indicate the same variable and they are going to get add up to give us 4x square. Alright, now we are getting only one term, so this is not a binomial. In fact, this is a monomial. So if somebody asks x square plus 3x square, then we can say that this is not a binomial because the terms have to be dissimilar. I hope you understood the meaning of binomial. Right, so this chapter is completely based on binomial. It means we will always have two dissimilar kind of terms or variables. Let me take you to earlier classes in which you read or you memorized some identities like a plus b whole square, a plus b whole cube. If I write them down one by one, a plus b raised to the power 0 will give us 1 under the condition that a plus b is not equal to 0. Because any finite quantity other than 0 raised to the power of 0 will give us what? 1. Similarly, a plus b raised to the power 1 is going to be what? A plus b. Now this is very obvious. A plus b whole square is going to be what? A square plus 2ab plus b square. And a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. These are some of the identities that you have already learned in your lower classes. Right. Now I can even write a plus b whole raised to the power 4. This will be equal to a raised to the power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b raised to the power 4. Alright, for now you can use a plus b whole cube multiplied by a plus b in order to get this expression. Alright, so these are the identities. Identities means they are satisfied for all the values of A and B. For all the values of A and B, LHS and RHS are going to be same. Alright, but we are interested in knowing how it is connected with binomial. Suppose I write indices, various kind of indices over here. Indices means nothing but exponent or power. Okay? The number that has been written over here are called as indices, power or exponent. And here I am writing down coefficients. Alright, so as you can see, when index is 0, the coefficient is 1. When index is 1, we are having two coefficient. One coefficient is corresponding to A, that is 1, and another corresponding to B, that is also 1. So when the value of exponent is 1, we are having two coefficients that are 1 and 1. Alright, when value of power or index is 2, I am having coefficients as 1, 2 and 1 respectively. So I am going to write them 1, 2 and 1. And when index was 3, I was getting coefficients as 1, 3, 3 and 1. So here I am writing down as 3, here 1, 3, 3 and again 1. Alright, so let me take you to this part. If you carefully observe, then here a pattern is being made that all the first element over here is 1, first element over here is also 1, here is also 1, here is also 1, and the elements at extreme or the numbers at extreme are also 1, 1, 1. Everybody is getting up till this point? Now, what about this 2? How am I getting this 2? This 2 is being added 1 plus 1. This 2 is a result of addition of 1 and 1. Which one? This one and this one add up to give us what? 2. And this 3 is a result of addition of this 1 and this 2. 1 plus 2 equals to 3. This 3 is also the result of addition of this 2 and this 1. 2 plus 1 is also equals to 3. So if I ask you that can I continue this series? The answer would be yes. If the index is 4, what are you going to write over here? Here we are going to write 1 only. Again, here we are going to write 1 only because 1 is coming at the extreme ends. Now, what about this number? How are you going to write this number? This number is nothing but the addition of the numbers in top left and top right. That is 1 plus 3, and 1 plus 3 equals to what? 4. So this number is going to be what? 4. Again, the number coming at this place will be addition of 3 and 3, which is equal to 6. And number coming at this place will be the addition of this 3 and this 1, which is equal to 4. If you observe carefully, then we are getting a triangle. We are getting what? A triangle. See, this is based on the pattern of a triangle in which all the extreme end terms are equal to 1. And the terms other than 1 that are in the middle are observed or are obtained by adding the numbers in the top right and top left of that number. So this 3 is obtained by adding this 1 and this 2. Alright, let me highlight. This 3 is obtained by adding this 1 and this 2. This 4 is obtained by adding this 3 and this 1. This 6 is obtained by adding this 3 and this 3. Alright, so this is a triangle which is known as very famous triangle. This is known as Pascal triangle. It has been named on the French mathematician Blaise Pascal. Now, why are we studying Pascal triangle? Why are we interested in observing this triangle? Because this triangle is directly related to the binomial theorem. Here you can see that a plus b raised to the power 1 is 1 into a plus 1 into b. So we can connect it with this triangle that coefficients are written for a plus b raised to the power 1 as a raised to the power 1 plus b raised to the power 1. The coefficient of a plus b का whole square is a square के साथ we have 1, with ab we have 2, and with b square we have 1. So the coefficients are written over here. a plus b के whole square में जो terms आते हैं उनके coefficients को हमने यहाँ पर लिख रखा है 1, 2 and 1. And a plus b के whole cube में जो coefficients हैं 1, 3, 3 and 1, those coefficients have been written over here 1, 3, 3 and 1. So a plus b के whole power 4 में जो coefficients हैं those are written over here 1, 4, 6, 4 and 1. So basically Pascal triangle gives us the idea, the exact idea of the coefficients of each term involved in the binomial expansion, where index has to be non-negative integer. Right? Index can be 0, it can be 1, it can be 2, it can be 3, 4 and so on. Alright, now if I consider the variables, then what is happening? The highest power of variable over here is how much? 2. And the highest power of another variable is also equal to what? 2. And upon going from this step to this step, the variable's power is getting reduced. a की पावर 2 से 1 हो गई और b की पावर 0 से कितनी हो गई? 1 हो गई. So a का पावर डिक्रीज हो रहा है but power of b is getting increased. Alright. Similarly in a plus b whole raised to the power 3, here we had a cube. Let me write it down. a plus b whole raised to the power 3. First term is a cube because a will have highest power as 3, and in the next term the power of a will decrease and become a square and the power of b will be introduced. In the again next term, the power of a will again decrease from a square to it becomes a, and power of b will increase, it becomes b square. And in the last term, the power of a becomes 0 and power of b becomes 3. Alright, and the coefficients we are getting from Pascal triangles, that is 1, 3, 3 and 1. That's it. We are done with the expansion of a plus b whole cube. So I think now you got the idea that how I have written the expansion of a plus b whole raised to the power 4. First of all, the power of a will go maximum how much? 4. And then in the subsequent terms, the power of a is getting reduced by 1 unit and power of b is getting introduced or increased by 1 unit. Alright, I hope everybody is getting till here. Now we are going to see the generalized form of Pascal's triangle or binomial theorem. The theorem says that a plus b raised to the power n, here I am taking n as natural numbers. N belongs to the set of natural numbers, or we can say that it is positive integer. So the index or the power or the exponent, which is n over here, that can be only natural number or positive integer. Alright students, so the theorem says that a plus b whole raised to the power n can be written as or will be written as nc0 a raised to the power n b raised to the power 0 plus nc1 a raised to the power n minus 1 b raised to the power 1 plus nc2 a raised to the power n minus 2 b raised to the power 2 and so on. This will continue till the last term, which will be ncn a raised to the power 0 and b raised to the power n. Alright, so this is what is called binomial theorem. Don't worry, we are going to prove it. But for now, you should understand that this is the binomial theorem, that a plus b whole raised to the power n is equal to nc0. First term is nc0 I hope you are familiar with NC0. It is the number of ways of selecting 0 objects out of n objects. So NC0 is multiplied with a raised to the power n, this is n, and b raised to the power 0. And in subsequent terms, as we are moving forward, the power of a is getting reduced while power of b is getting introduced or increased. Alright, so far so good. So now, before taking any illustration or example, let us first understand its proof, and we will be proving it with the help of permutations and combination. Alright, if you pay attention, it will be easier for you to prove this theorem with the help of permutations and combination. Let us see a plus b whole raised to the power n. Now whole raised to the power n means a plus b is multiplied how many times? N times. So I am writing down the same bracket or multiplication how many times? N times. So here I have multiplied the a plus b how many times? N times. Alright, I hope everybody is getting till this point. I have written down a plus b whole raised to the power n in multiplication format. Now, you have to think about each and every term using the concept of permutations and combinations. In fact, you don't have to focus on permutations. The only combination word will be sufficient over here. Now, b raised to the power 0. B raised to the power 0 means if I am going to multiply each and every term with each and every bracket, how am I going to get b raised to the power 0? B raised to the power 0 means no b. B raised to the power 0 means we don't want any b from these brackets. There are n brackets. So how can I do this? Now we have n brackets. Alright, out of these n brackets, if I choose b from none of these brackets, then it can be done in how many ways? NC 0 ways. If you have n objects and you have to choose none of these, so how can you do? You can do it in NC 0 ways. Alright, I hope everybody is getting till that point. So b raised to the power 0 is done. Corresponding to b raised to the power 0, NC 0 will come. Why? Because we say that we don't want any b from any of these brackets. It means that we are not taking or selecting any bracket for b. So from every bracket, what will occur? From every bracket, only a will get multiplied because b raised to the power is 0. So when a is being multiplied with each and every bracket and we have n brackets, what we are going to get with b raised to the power 0? We get a raised to the power n. So students, we have deduced the first term, that is NC0 a raised to the power n and b raised to the power 0. If you haven't understood so far, let us consider in second term. Maybe you get over there. In second term, now b raised to the power 0 is done. Now we want b raised to the power 1. It means we want 1 time b and remaining a. Alright, b raised to the power 1 means that out of these n brackets, I am interested in only one bracket from where I am going to take b. Let us suppose the first bracket from where I am taking b, and from rest all other brackets I am taking a. Now when a is being multiplied in the remaining brackets, the power of a will become n minus 1. Why? Because the remaining brackets are n minus 1. And when from the first bracket I am taking b along with these a, so in all I am going to get a raised to the power n minus 1 and b raised to the power 1. But how can this be done? In how many ways this can be done? I can select b from this bracket, from this bracket, from this bracket. In any of these n brackets, I have to make a selection of one bracket. So this can be done in how many ways? Out of n, I can select one thing. In how many ways? NC 1 ways. So that's it. We are done with the second term of the binomial, that is NC1, a raised to the power n minus 1 and b raised to the power 1. Third term देखते हैं. Now we want b raised to the power 2. Now start thinking on your own and start analyzing, start using your brain that we want b raised to the power 2. It means b has to be taken from 2 brackets. Alright, and from remaining n minus 2 brackets, we want a. So we have n brackets. Out of these n brackets, we have to select 2 brackets for b. Let us consider these are the 2 brackets. From the remaining n minus 2 brackets, I am selecting a. So a will be coming n minus 2 times. So a raised to the power n minus 2. And b is coming 2 times. B multiplied by b give us b square. Now in how many ways this combination can be made? That in how many ways out of n brackets I can select any 2 brackets for b? It can be done in NC2 ways. Alright, similarly for the next term we want b raised to the power 3. So I have to select 3 brackets so that I can have 3 b's, and b into b into b will be b cube. Now remaining n minus 3 bracket I will get a. So it becomes a raised to the power n minus 3. But in how many ways I can select 3 brackets for b out of n? This can be done in NC 3 ways, and so on. Finally, when we have to make b raised to the power n, a raised to the power 0, it means out of all the brackets I am multiplying b, and out of none of these brackets I am multiplying a. So out of all the n brackets I am taking b, it means I am selecting all the n out of n brackets. So this can be done in how many ways? This can be done in NC n ways. Hence proved. The binomial theorem is proved with mere logical thinking and with the help of PNC concept. Alright, so I hope that you people are also able to prove this theorem. This theorem states that a plus b raised to the power n is equal to NC0 a raised to the power n b raised to the power 0, NC1 a raised to the power n minus 1 b raised to the power 1, and so on. Last term is NCn a raised to the power 0 and b raised to the power n. And we have proved it. Alright, let's take an example in order to understand the theorem. Suppose you have to write down the expansion of 2x plus 3y whole raised to the power 5. Suppose we have to expand it. So here this term becomes a, this is b, and this becomes n. So a is equal to 2x, b is equal to 3y, this is the binomial, and n equals to 5. So the expansion is going to be, first term was what? NC0 a raised to the power n and b raised to the power 0. Second term is NC1 a raised to the power n minus 1, that is 4, and b raised to the power 1. Third term is NC2 a raised to the power 3 and b raised to the power 2. Fourth term is NC3 a raised to the power n minus 3, that is 2, and b raised to the power 3. Fifth term would be 5c, 4, 2x raised to the power 5 minus 4, and 3y raised to the power 4. And last term is 5c, 5, 2x raised to the power 5 minus 5, and 3y raised to the power 5. This is going to be the expansion of 2x plus 3y whole raised to the power 5 according to the theorem of binomial. Alright, so I hope you people have understood and you can do this example on your own. Alright, I have explained it. So we will be continuing with binomial theorem. I will be taking it further in the next class. That's it for today's lecture.